I am Satoshi Yamada from Kyoto University. I will talk about the Torus structure and supermassive black hole growth emerging with the luminous infrared galaxies revealed with the X-ray and mid-infrared spectroscopy. The results in this talk are based on these papers. I introduced the infrared sources, which are subject to the central AGN and starburst activities hidden by gas and dust. Particularly, with the luminous infrared galaxies, that is ULIRGs, are dominant at high Z, and they have large infrared luminosities. It is known that many of them are interacting galaxies, so that they are considered to be a key population for the galaxy and supermassive black hole co-evolution. Many theories predicted that during the final phase of a merger, the central region becomes deeply enshrouded by gas and dust, called as buried AGNs. Moreover, it is reported that the super-Eddington accretion is triggered in the peak phase of a merger. Whereas it is difficult to test these scenarios observationally because of their sake of obscuration. Thus, the mid-infrared and X-ray observations are useful to investigate the buried AGNs in ULIRGs because of their high penetrating power against obscuration. Last year, we proposed a new diagnostics for the Torus structure by using the nuclear twelve micrometer and oxygen for luminosity ratio. The nuclear twelve micrometer emission is derived from the thermal torus dust, while the oxygen for emission is from the narrow line region. Both of them are less affected by the dust obscuration and the contamination from the starburst activities. Thus, if the AGNs are buried, they should have smaller oxygen for luminosities relative to the nuclear 12 micrometer luminosities. Actually, we adapted this criteria to the 23 local ULIRGs, and the graph shows the result. The color represents the merger stage. The red symbols are AGNs in later stage mergers, and they have smaller oxygen for luminosities. Thus, we found that AGNs in non-merging and early stage merging ULIRGs are not buried, but AGNs in late stage merging ULIRGs are deeply buried like this picture. To confirm whether or not such distinct characteristics seen in X-rays, the X-ray follow-up study is also important. Next, we also investigate the AGNs in ULIRGs using the X-ray data. Particularly, new observations reveal the properties of obscured AGNs. Kyoto reported that the fraction of constant AGNs in ULIRGs becomes larger with merger stage. However, the individual Torus structures and accretion rates are yet unknown. Here, to investigate the individual covering factors, we adopt the X-ray Clampy Torus model, X-Clampy, which is one of the most realistic models. To constrain the Torus parameters, we use most of the available data of Newster, Chandler, XM Newton, Suzaku, and Sweet for local 57 ULIRGs in gold sample, which corresponds to about 85 galaxies. Adapting the X-Clampy model, we identified about 40 AGNs in our sample. The right panel shows the relation between the galactic separation and the hydrogen column density of the torus. We find that the line of sight column density becomes larger with merger stage, reported as Rich et al. 17. Finally, we obtain the relation of torus covering factors and Eddington ratios for 20 AGNs with merger stage. The gray area represents the typical relation among Swift-Butt AGNs reported by Rich et al. We find that some AGNs in later stage mergers have large covering factors even with high Eddington ratios. Our results suggest that the AGN in the final phase of a merger become buried despite of its high Eddington ratios, like this picture. This is the summary slide. That's all. Thank you for your attention.